All right, everyone, I'm going to go ahead and get started. People are still logging in, but I can do the introduction. First, good morning. Thank you, everyone, for coming to today's webinar. This is the November California-Nevada Drought Early Warning System Drought and Climate Outlook webinar. Thank you for those that have joined us before and those that are joining us for the first time. My name is Amanda Sheffield, and I am at Scripps Institution of Oceanography in San Diego, and I'm the Regional Drought Information Coordinator for NIDIS in California and Nevada. This bi-monthly webinar series is designed to provide the region with timely information on current drought and climate status, as well as associated impacts and preview of developing climatic events. This webinar is being recorded, and the recording, along with the presentation slides and a 2-page summary flyer, will be available on drought.gov later this week. The National Integrated Drought Information System, or NIDIS, works to provide a better understanding of how and why droughts affect society, the economy, and the environment. And we do this to improve accessibility and use of early warning information for drought and risk management. And we do this building off a network of regional drought early warning systems to create a national drought early warning system. And as you can see from the map here in California, Nevada, we are one of the systems. So what is a drought early warning system? It's a way to utilize new and existing partner networks to optimize the expertise in these federal, tribal, state, local, and academic partners in a region. And that way we can try to make climate and drought science and impact data readily available, easily understandable, and usable for decision makers. And that way we can improve the capacity for making better decisions, better monitoring, better forecasting for planning and coping with the impacts of drought. Here in California, Nevada, we do have a strategic plan that's now up on drought.gov, and this past summer we had our first annual coordination workshop in June. Out of that workshop, we got a lot of great feedback on next steps and different things to think about in the region for drought mitigation purposes, including having quarterly key stakeholder calls. The next one is December 18th. If you're interested in being part of this network and these key calls, please contact me. And another big thing that we have out right now is a regional drought-related activities and resource matrix. So we're trying to simply catalog a lot of the activities and the great innovations that came out of the last drought and thinking forward for the future. And so we've created this Google form here, or you can contact me. My email will be at the end, and how to contribute to this activities and resource matrix so that we can have, different people who, depending on their level of interest or need in information, be able to click on, oh, this activity is going on in this region by this person to reach this goal, etc., and things like that, to hopefully improve coordination and between different agencies, different partners, and different activities. Just before we get on to the rest of the agenda, I wanted to quickly just let people know about some new things that have come up in the region. A couple different partners in the region have worked on these new definitions for the American Meteorological Society. Basically, once these sort of newer topics have come out through science and science advancements, a peer-reviewed definition helps them a long way get to different steps and on the same page across different science and partners. And two new ones that have recently come out include atmospheric rivers, which, if you're here in California, Nevada, you're probably familiar with them. Are these long, narrow, transient corridors of horizontal water vapor transport that, when they interact with our coastal areas, can often cause large precipitation events, and they're key to our water resources in the region. As well as another new one from snow drought, which needed defining in certain ways because we can have a dry snow drought versus a warm snow drought, or both factors coming into play. And recent work has shown why this definition was necessary and how we're thinking about it going forward with the science. With that, I'll get back to today's webinar. First up, we're going to have the California Nevada Drought and Climate Status Update with Dan McAvoy from the Western Regional Climate Center. Then we're going to have the Drought and Climate Outlook from Andrea Baer, who's with Western Region National Weather Service. And then for the latter half of the webinar, we're going to go over some tools for tracking precipitation throughout the water year and other tools from other partners, including the California Nevada River Forecast Center, CW3E, which is a center here at Scripps, and then myself, and I'm going to go over from the local NOAA RISA program, drought.gov, and others. With that, I'm going to pass it over to Dan McAvoy if he's ready to do the first presentation.
All righty, thank you for the introduction, Amanda. Can you see my screen now?
Yep, you should be good to go.
All right, thanks a lot. My name's Dan McAvoy. I'm a climatologist here at the Western Regional Climate Center, which is housed at the Desert Research Institute in Reno. And I'm going to give you guys an update today on where we stand so far throughout this water year and the current drought conditions and what the climate's been doing thus far this water year. So I want to start out with the big picture, just showing what the latest U.S. Drought Monitor is depicting for the region. This is from last Thursday, the 21st. And basically, if you focus over there on California and Nevada, most of the region is drought-free, with the exception of Southern California, coastal regions. There are some areas of D1, which is moderate drought, and there's a small patch of abnormally dry in southeastern Nevada. But pretty much last winter wiped out a lot of the drought over the northern tier. And there are some long-term lingering conditions in Southern California, including groundwater and reservoir levels and long-term precipitation deficits, which is why that D1 is still showing up there. I just wanted to show you that there have been some minor changes over the past month. D0 has been expanded. The abnormally dry conditions have been expanded slightly in parts of coastal California and Southern California, and also that area of southeastern Nevada. But other than that, there hasn't been much change in California and Nevada since last winter and spring, where we saw those big changes from drought over much of the region to no drought at all. So I don't think many people have forgotten, but just in case, I wanted to give everyone a little refresher on what happened last year. So this is the water year precipitation, which was October 2016 through September 2017. These are showing the percentile rankings based on PRISM data, which goes all the way back to 1895. And so anything in that darkest green color indicates the record wettest water year. So a lot of the northern Sierra and central Sierra and portions of northwest California and northern Nevada saw record wet conditions last water year. Now, the further south you go, most of the region was still above normal, but it wasn't anything like we saw in the north. And so again, when you look at, say, southern coastal California, after 4 years of pretty severe drought, 1 year of about average or even slightly below in some cases, didn't do that much to erase the long-term deficits, which is why there's still those long-term persistent conditions showing up in the U.S. Drought Monitor over those regions. So what do we look like so far this water year? So this is the precipitation percent of average from Climate Engine using University of Idaho's gridded meteorological data, which is a 4-kilometer spatial resolution, similar to the same spatial resolution as PRISM. And so this is showing October 1st through November 24th. And the first thing that really stands out is that it's been fairly wet in the northern Sierra and parts of northwest California. But as you go farther south, there's a very sharp gradient. The storms really haven't been making it very far south this year. And so much of Southern California and Southern Nevada are, less than 5% of average or haven't seen any precipitation at all this water year. So a very strong gradient so far north to south. So I wanted to illustrate that gradient even more by showing the three different, the California Department of Water Resources precipitation indices. I want to start in the north with the Northern Sierra 8-station index. And the map in this image there shows the 8 stations that are used. And so the traces show individual years, and then the blue shading shows the long-term average from 1966 to 2015. And again, the green line there shows last year was the record 94.7 inches, about 6 inches higher than the 82-83 year, so just an incredibly wet year. But now if we focus on this year, we're currently at 134% of average. And so you can see the blue line there going through towards the end of November. So November's been a fairly wet month. It started off pretty dry in October, and then we've had a fairly wet November in the north. And so well above average in the northern Sierra. Now we move to the Central Sierra. This is the Central Sierra 5-station index. This is currently at 68% of average, so already going from north to central, there's a very large difference in the percent of average, only 4.3 inches if you average over those 5 stations, well below average. And then we continue to go further south to the 6-station index now. It's been remarkably dry compared to the Northern Sierra, and they're only at 38% of average, only 1.5 inches so far averaged over those 6 stations. So just wanted to highlight again this gradient with the storms not really making it too far south so far this year. So temperature also plays a big role in drought. It increases the severity, it increases evaporative demand and evapotranspiration, and plays a role in things like snowpack and snow levels. So it's definitely important to keep an eye on what the temperatures are doing. So this is another graphic from Climate Engine showing the average temperature anomaly for October 1st through November 24th of this water year so far. And generally, it's mostly oranges and red. So it's been pretty much a warmer than average year with a few pockets, a few exceptions. But if you look at the Sierra region, has been well above average, as well as Southern California has been incredibly warm. And Thanksgiving this past week saw all sorts of record high temperatures, not just in Southern California, but throughout many parts of California and Nevada. So off to a fairly warm start with a few exceptions. And the warmer temperatures have led to some higher snow levels with the storms that we've had so far. And I'll show some examples of what's going on with the snow levels and the snowpack. So this next graphic is showing the SNOTEL, the percent of median snow water equivalent from the 25th is when this was last updated a couple days ago. It's still early in the snow season, but it's usually around mid to late November when a lot of these stations in the Sierras start accumulating their snowpack. So it's important to pay attention from the get-go. So it's really interesting here. I showed you before that most of the Tahoe and Northern Sierra region had well above average precipitation. But what we're seeing here in the snowpack is we're seeing some of these dark blue dots, which is greater than 200% of normal, very close to these orange and red dots, which are zero snow at all, or 5 to 10% of average. And this is an elevation gradient. So basically, these red dots are all the lower elevation stations and mid elevation. And then the blue dots are showing that the high elevation stations actually have a decent snowpack right now. We can look at that through a couple of different stations. And so what it was nice that Amanda showed that AMS definition of snow drought, and that made it into the AMS glossary. That's great to see. And so we're actually in an early season snow drought right now. This would be the warm type of snow drought that Amanda mentioned at the mid and lower elevations. And so this is showing Rubicon number 2 SNOTEL, which is on the west shore of Lake Tahoe at 7,619 feet. So for the Tahoe area, that's about a mid-elevation station. It's not that low. And then on the right is Mount Rose ski area, which is one of the higher elevation stations at 8,801 feet. And so this is showing the gray line is the average precipitation accumulation for the water year. And then the red line is the median snow water equivalent for the water year. The black line is what we've seen so far this year for precipitation, and then the blue line is this year's snow water equivalent. And so you'll see that we had this very potent large storm a couple of weeks ago here that dropped 6 to 8 inches or even more liquid equivalent, or 6 to 8 inches of precipitation over the region. But this was a very warm storm with high snow levels throughout much of the storm. And so even here at 7,600 feet, we had a little increase in the snow water equivalent, still less than 2 inches of snow water equivalent. And then we had a lot of it melted this past week when it got warm. We saw a very small bump with this last storm, but still well below normal for this time of year. Now, if you focus on the right over at Mount Rose, they had the same precipitation jump, but also a very large snow accumulation. Mount Rose Ski Resort reported 30 to 40 inches of snowfall from this storm, so that boosted their snow water equivalent well above normal, and they're still above normal, and had another decent boost from this storm we've had the past couple of days. So it is early in the season, but it's important to track these snow droughts throughout the year and not just look at what happens at the end of the year. And so we'll keep an eye on this as we go throughout the season. Hopefully we'll get some colder storms. This is just another way to look at the percent of average snow water equivalent, but looking at basin averages. You can see Tahoe is below average at 78%. The Truckee, Carson, and Walker are really reflecting those higher elevation stations that have well above normal SWE. And then as you go out into northeast Nevada, they've had a lot less precipitation, and so their snowpack is not doing so good right now out in the northeast mountains in Nevada. So moving on to the reservoir conditions. So this is showing the California reservoir conditions from CDEC as of November 25th. And so these bucket diagrams show you basically the blue is the percent of capacity, and then the red line there and the red number shows you the percent of the historical average. And so if you look around the state, nearly all of the reservoirs are above 100% for the percent of the historical average. The only exception being Lake Oroville, and then in the south, Lake Paris. And I don't know the operation details of Lake Oroville. Maybe at some point someone can chime in on that, but I'm guessing it's below average due to some management practices, just seeing how far above average all the other reservoirs are. So in general, with the exception of maybe Southern California, some of the reservoirs down there, most of the state, the reservoir conditions are in pretty good shape. And one that isn't on that map is Lake Tahoe, which provides water to pretty much all of northwestern Nevada, a very important water resource for the region. So I wanted to show what Lake Tahoe is doing. This is showing since the beginning of the last water year, so starting October 2016, and at that point, Lake Tahoe was below the natural rim, below 3 foot gauge height, and so there was no water flowing into the Truckee River, and it was very low conditions on the lake. And of course, we had that exceptionally wet year last winter, and we saw this tremendous rise in the lake of greater than 6 feet to basically maximum capacity, and now the lake came down a little bit throughout the summer, but not very much, and now we're already see gains in the lake again from these storm events. And just to look at a little bit longer perspective, going back through the past droughts, so this is showing from October 2010 through present. You can see the decline after the 2010-2011 winter down to these near record low levels in 2016 and early in 2015 and 2016. And then this tremendous rise this past year. And so right now, the lake's probably not going to get any lower. Maybe it'll fluctuate a little bit as we go through the winter, but it's likely going to start rising again. And Tahoe's going to fill up pretty quickly again, and they might have to let out some water during some storm events this year if we wind up with some more large storms. So lastly, I just wanted to touch on the ENSO conditions. Andrea's up next with the Outlook, and she's likely going to talk more about how this is going to could potentially impact our weather this winter. But we are officially, La Nina conditions are officially present according to the Climate Prediction Center. So this map showing the latest sea surface temperature anomaly from November 11th through November 18th. And so along the equatorial eastern Pacific there, we can see those darker shades of blue indicating cooler than normal sea surface temperatures, and we are currently in a La Nina state in that region. And I also just wanted to point out in the northeast Pacific, where for many years during the last intense drought, we had this very warm blob of warm water in the northeast Pacific. That isn't really there anymore. It's pretty near average right now, or even a little cooler than average. So, but it's still not clear exactly how that will affect our weather this winter. And one more slide, just showing some of the numbers for the Nino regions, where this is the regions that they use to indicate whether you are in a La Nina or an El Nino or neutral. And so all four of the indices are below average right now. It's definitely cooler as you go further east. So Nino 1.2 is the coolest right now. Nino 3.4 is the one that's most commonly used to identify El Nino and La Nina conditions, and so that's at negative 0.8. But you can see the trend of we had warmer conditions this past summer that have been cooling throughout the fall and are projected to cool as we go into the winter. So just to summarize, most of the region is currently drought-free, again, with the exception of the Southern California coast, where some of those long-term impacts are still present. Good start to water precipitation in Northern Sierra and Northwest California, but pretty dry everywhere else and very dry or no precipitation in some parts of Southern California and Nevada. Storms just haven't been making it that far south yet. We do have some early season warm snow drought at the mid and lower elevations in the Sierra due to those warm temperatures during the larger storms that we've had. In general, the reservoirs are in really good shape due to the exceptionally wet winter we had last year. And La Nina conditions are present, and they're expected to persist throughout the winter. And that was all I had. So I don't know if we'll take questions now, or we'll leave that to Amanda.
Thanks, Dan. Yeah, I forgot to mention we normally do questions at the end. If there's any quick ones, I can try to grab them now, but I don't see any. So people go ahead and keep typing your questions in, and we'll get to them later. But I'll go ahead and pass it over to Andrea to do the Outlook.
Okay. All right. I have to warn everyone, there is drilling going on below me, and so it kind of feels like I'm working in the dentist office today as opposed to a National Weather Service office. So I've put my phone as close to me as I can, but there may be some obnoxious noises going on and off. It happened about 4 times during Dan's talk, so we'll see. So bear with me if that happens. Okay. Thanks for having me, Amanda, and I'm going to talk a little bit about the climate and the drought outlooks that are coming from NOAA. And as Dan mentioned, we are in La Nina conditions. There is a La Nina present out there in the Pacific, and therefore the Climate Prediction Center has issued their La Nina advisory. And they're expecting that to continue through our winter. I've put some links here for you. The ENSO diagnostics discussion, which the Climate Prediction Center updates every second Thursday of the month. So it'll be coming up in a couple weeks in December. This is the link to that. You can check back. And then the ENSO blog, NOAA does an ENSO blog on climate.gov. And most of my, a lot of my graphics I take from climate.gov. I think they have some very nice graphics and features and easy to understand stories on their ENSO blog. So there's a link to that, and they update that about twice a month. So periodically check back on that for stories. Okay, this is a busy slide. Stay with me. My point in showing this slide is that not all La Ninas are the same. And what you can see here, this is for a typical season for December, January, and February. And it starts out with all of the different strong events, and there have been 21 of them since 1950. And it starts out with all the strong events, and then it shows you the moderate events, if you can see that right there. And then it starts the weak events. And it does the same thing for precipitation, and it gives you the year up here. And as you're looking at this snapshot of all of the La Nina events, it really shows the variability that can happen during a La Nina. We do get some general tendencies, and I'm going to show you those general tendencies in a minute, but really the screaming message is things can happen that are different than what we expect during those general tendencies. I think California and Nevada folks remember that from the El Nino that happened a couple years ago. There's just a lot of variability, so you can't totally bet the farm on, on when we have a La Nina or an El Nino, and this really explains that well. And I will give my slides to Amanda, so these will be available to you, and you can go back and look at those. So this is what I was talking about just a minute ago. There have been 21 events, and this shows them all put together and statistically looking at where we've had temperature anomalies that are higher than normal or below normal in temperature. So this is all of the events put together, and you can see that there's a general tendency for cooler conditions, cooler than average in the northern plains. California is a little cooler than average, and the south and southeast warmer than average. But if you go through and you take those apart, and you take your 21 samples of La Nina episodes, and you split them between events that happened prior to 1985 and those that happened after 1985, and that's just really splitting the episodes in half there. 10 and 11 episodes. But if you go ahead and do that, you can see for temperatures early on those relationships that you could see before in that where I combined all of them together. You can really see there is cooler than normal, but then as you move into the episodes that have happened since 1985, there really doesn't tend to be a relationship. You can see the warmth sort of spreading towards California and Nevada, but really not much of a relationship. So getting a lot more washed out as we move into the latter part of when we've been keeping track of La Nina and El Nino episodes. Okay, so the same thing was done for precipitation, combining all 21 events that have been La Nina events. And you see with precipitation, there tends to be a dry signal in California and southern Nevada, really across much of the southern portion of the country, and then wetter than average in some of the different northern areas. But when we separate those two, again, you kind of see that washing out a bit. California does still look like it has a general tendency to be a bit drier, southern Nevada as well, but really a little more washed out than when I combine all of those events together. This is the brand new ENSO blog entry, and again, that can be found on climate.gov, and I like these graphics very much. So this is average snowfall patterns during La Nina, so again, general tendencies here. And if you look at average snowfall for all those 21 La Nina episodes, you really can't see much but in the very northern portions. Otherwise, there's not a lot of information going on for the southern 2/3 of California and Nevada, but it's looking like the average patterns are above average. If you just take the weak La Nina events, here's what you get. A little more information during weak times, but not a whole lot. And then here's when you take strong events. And we are expecting this La Nina event to be on the weaker side. I'll show you that with some of the forecast graphics in just a moment. So looking at this one more is what I would tend to do. So looking back at where we've been the last dozen years or so, you can see that very weak La Nina event we had last year, starting in July, August, and September, and lasting through November, December, January season. Here we are right at the end of August, September, and October, and we're just about at that threshold of negative 0.5 that is part of the definition for when we're entering La Nina conditions. Obviously, we expect this to be negative 0.5 or lower when the all of the November data comes in. So this just gives you a snapshot. The pink areas are El Nino events, and the blue areas are La Nina events. So looking back, Dan covered this a little bit, but most recently, October and November, we have definitely cooled off up to the date line and eastward, and then warmed up a bit in the Western Pacific. So this is where we currently are right now. And Dan showed this, so I will skip over that. Looking at the upper ocean, the temperature anomalies in the upper ocean, which is about 0 to 300 meters down, you can definitely see that we've cooled off in that upper ocean since towards about the latter part of July, and we've consistently gotten cooler in that area. Okay, looking at the forecast, this graphic is updated from the NOAA's Climate Prediction Center and the International Research Institute, and it takes into account the forecaster information and input, and also the model input. And looking through this, you can definitely see that through our winter, the models and the forecasters are favoring that we stay in La Nina conditions or La Nina episodes through about February, March, April, and then after that, looking more moving into ENSO neutral territory. This is the forecast plume for El Nino and La Nina, and this is the magic area right here that we look at, that magic, I should have drawn a line for you right there. But this shows you the different dynamical models right here and the different statistical models. If you look at the dynamical average, again, the event's supposed to stay with us through about February, March, April, and then start warming up again. Also, the statistical models do show that, but they're keeping things right on the border there of weak La Nina territory. So we'll see what happens, but it's a little bit harder to see when you look at it yourself. Hopefully you can see that, that average line for the dynamical and statistical models. So these are NOAA's official 3-month temperature outlooks. I like these graphics very much, but there is one small misleading part about these that I just want to warn you about. When it says warmer or cooler and that word, those words are put into those stronger categories, we're not telling you it's going to be cooler here versus here. Basically, this is a higher favorability. So there's a higher favorability for warmer than average temperatures in here. The odds are shifted more in the favor of warmer. So you can kind of think about it as a confidence. So we're definitely a bit more confident that the temperatures are going to be above average in these areas. So you can see for December, January, and February, so into the heart of our winter, a little bit of higher favorability for warmer than average in Southern California. Still some shift in odds towards warmer than average in Central California. And really, we don't know. It could go any way, either way, in the northern portion of California. Our tools really aren't giving us anything there to give you any sort of confidence in a forecast. And here's precipitation, and looking like the southern half of California, expecting drier than normal conditions, and with a little more confidence of that, or higher shift in odds in the southeast portion of California. And then moving on to the seasonal drought outlook that was just released. Dan covered the drought monitor, but this is the drought outlook. So what are we expecting over the next 3 months? Expecting these areas in California in brown to persist, and then drought development to be more likely in these areas that are yellow. And it's already showing up on the drought monitor. A lot of that is probably geared towards the general tendency of drier conditions in Southern California during La Nina events. So just to summarize, we are in La Nina conditions in the Pacific Ocean. We do have a La Nina advisory. We do expect this event to be on the weaker side and probably short-lived. So once we start moving into spring, definitely conditions are expected to go back to that ENSO neutral range. It really has been pretty consistent in that forecast. And again, I'd like to point you to the ENSO diagnostics discussion and the ENSO blog that is on climate.gov. And with that, I'll pass it back to you, Amanda. Thank you.
Thanks, Andrea. Just a quick reminder to everyone, please type in your questions. If you have questions, I think I might have saw a hand raised with the program, but we're actually going to go through the question box, so go ahead and type them there. I don't see any other questions right now, so I'm going to go ahead and move over to the next part of the presentation, which is going to be, while I was putting together this webinar, I thought it's probably a good time of the year to think about what tools do you guys have at your fingertips to think about how you're going to track precip or other impacts or other things along the way. And so we asked a couple different partners who have different focuses and for their organizations or centers to highlight some of the tools that they have. I'll note that these are obviously not all inclusive. There's many other tools out there, including ones that, for example, that Dan McAvoy showed or Andrea showed with the climate.gov. with CDEC, which is the Department of Water Resources in California's tools. The WRCC has a lot of tools as well. So this is not meant to be all-inclusive, but just to highlight a couple examples of things you might need. First, we're going to start with Ellen Haynes, who's with the California Nevada River Forecast Center. Ellen, are you there?
I'm here, and you're able to look at my screen, right? Transfer over to
I will transfer screen over to you right now, and then you can go ahead. Yep, and we can see the website.
Okay, very good. And you can hear me okay?
Yep, it's great. Go ahead.
Okay, good. Yeah, so this is basically the front-facing page of the California Nevada River Forecast Center, and it shows, these green dots represent our forecast points for, river forecasts that go out to 5 days into the future. For the purpose of this call, and I thought I'd introduce some of the other tools that we have that you can access. And so I'll start with this top line up here where it says hydrology. You click on, if you go to there, you can kind of toggle or move down to water resources and choose that. And what comes up is a screen with the default of forecast flows showing you for all the different forecast points that we have. And just a quick visual, color reference there for where things are at. The initial thing highlighted is the water year percent of average. This is for the water year 2018, which goes from October 1st through September 30th of 2018, and showing you what the forecast is. So this would take into account, using our model based on what's happened so far, what the current soil states are, and taking into account the forecast for the next, basically 10 to 15 days, whatever the impacts of forecast precipitation are in there, and then applying climatology after that 15-day period to see where you'll end up. So this time of year, typically, you're going to end up it's going to show things, near average, because there hasn't been a lot that's happened so far. There's not a lot forecast, to really impact things. But as you get later into the year, the conditions can change. Like if you were to look at this, last spring, it would show things running much above normal for the water year, just because we would know what snowpack we'd have in place by then. Soil conditions were pretty much saturated, and it would take into account the latest storms and whatnot. So this shows you right now, we're kind of where you expect, near normal for most locations, although some areas are running above normal for forecast flows in these green dots in the Central Sierra there, where we've had kind of above normal precipitation. You can look at seasonal precip too. So if you click on the next one over, seasonal, this would be through the April, July volumes. Again, these aren't going to be all that revealing this time of year, because we don't know anything about the snowpack yet. There's been no snowpack developed, and it's really dependent a lot on that. So that'll be more important later in the year. But then you can start to look at things like going over, spring peak flow dates and all that as you get more interesting weather. Now, under the forecast flows, okay, if we go back to where we were, if you were to click on a station like, let's say, Oroville here, what the default product that would come up is this, what we call a trend plot. A little bit complicated graphic, but there's a lot of information in it. And what you'll see is these colors here on the left side is kind of where we're at right now at the end of, toward the end of November. These green X's that you see, that's every day there's a forecast. This is showing for the water year. So this is from October 1st through September 30th here on the right. Showing a forecast volume, and the most probable right now, it shows on this line right here, 4,170,000 acre feet of runoff, which would be about 93% of average or 110% of median. So again, this time of year, things are going to be near normal. But you can see how it trends every day. It kind of moves around, and where we had this big inflow just recently here on the 17th of 44,000 acre feet, that with the forecast started to sense that ahead of time, and so that the X's ticked up. Now we also plot the 10% exceedance in these blue dots every day here, and the 90% exceedance in the red dots. So you can kind of see the variability, and these are derived from our ensemble forecast, I should add. The green dashed line shows the median of runoff for that year, and then the darker dashed line shows the average. So medians tend to be a little lower than the average. The average is skewed a little bit by wetter years. The pink shading you see there, that's the cumulative volume on average. So, it goes parallel to the average line by the end of the water year. And then this kind of pinkish, darker line there shows the water year to date observation. So again, a lot of information in this graphic, but it's a good way to kind of track and see how things are trending. Every day you can look at the change. If there's a big storm coming, you could see it reflected in the forecast, especially as you get later in the water year. We could do the same thing. So this is available for other forecast points, and there's also a seasonal trend plot. So this would be for the April to July. You can click on that and see a similar thing, but it just shows this black line here starting April 1st, ending at the end of July, and showing you this expected runoff for that. So this is usually pretty interesting for snowmelt runoff, is the purpose of this. There's a bit of, there's also these accumulation plots. So if you look at the water year accumulation plot, this box right here in the matrix, a little different view of things, and it kind of shows you where you're at. This magenta line is the accumulated to date there, and so we're at 330,000 acre feet. And then these plots, dots, and lines here kind of show you the range, 10% to 90% exceedance, and then the green is the 50% exceedance, showing you kind of where you could end up at the end of the year. And the green lines you see are the actual individual traces of, so this would be running our hydrologic model out a year into the future and looking at, and then we can analyze that to look at what the exceedance probabilities are, and that's where these sampling dots are here. So that, any individual trace isn't really all that revealing, but it's the analysis of all of the traces together that gives you the idea of, statistically what to expect. So this has similar information. The blue shows the daily observations of flows there, and you can see that big peak on the 17th. You can see where we're at currently, as I was mentioning, and then where we expect to be. And so the 50% exceedance ends up pretty much around average for the year. Now, one of the things we added, because we had these dry years a few years back, all the drought years, we did a multi-year accumulation plot. So you could kind of see what using these plots, it was useful to see what your accumulative deficit was, because if you were just taking a snapshot of things, it didn't really give you a feel for how far behind you were, what you really need. We got a lot of questions from the media. How much precipitation would it take to, end the drought and such? And so we couldn't really, talk about ending the drought, since it's a political definition for that. But we could talk about what it would take to bring the flows up to normal, runoff to normal. You could look at precip, but precip, the amount of precip that you need to get to be normal is one thing, but then you also have to, consider the soil moisture deficits and all that. Well, our modeling system kind of integrates all that with the deficit in the soil moisture, and the end result is, okay, what are you actually going to run off? And so this plot was useful for that. And currently it goes back, a few years here to 2016, and showing you where we're at. Since we had such a wet year last year, we actually are running above average for this year so far because of the cumulative nature of this. And so these show you that from anywhere from the 10 to the 90% exceedance, and you know, it is possible, or and even also has the maximum amount trace, you know, from our ensemble runs. And if you look at that, there's some, you know, slight probability that we could exceed a record, but more likely we're going to be ending up somewhere above average for this cumulative period. All right, so I know this is a lot of information to throw at you, and again, you know, we'll answer questions at the end about these, but just to give you a little flavor of what's available on our website. Another thing that is probably interesting, I know for answering media questions and whatnot, you can look at historical flows. So here you can look at, this is for the inflow to Lake Oroville again, and the variability and annual precipitation and runoff, you can see highly variable there in these blue lines that show you each year from about 1900 or so on to the present time. The black line shows the moving 2-year average of flows, so that you can kind of, and then from this you can kind of see where the drought years are by these dips in a couple year periods, you know, of runoff. And then below this and then the red line there shows you based on the forecast for this coming year, where we expect to be, which is, you know, it's going to be near average. And then the table below ranks everything. You can look at it in terms of the annual flow. So if we click on that, I think that's the default. It shows you that it'll go from the driest to the wettest here. If you click on it again, it toggles it back to wettest to driest. So 2017 shows up there as the wettest year for this inflow to Oroville, and the second place winner was 1907, and 1983 came in third. If you look at 2-year, if you click on 2-year average, it starts with the driest to wettest. If you click on it again, it goes wettest to driest. So 1983 for a 2-year period, cumulative runoff, 1983 was the top one, and 2017 only ranked 7th. So the year, it's because of the previous year to, you know, 2016 it was pretty much average, and 2017 was well above. But if you average the two, well, it's still wet, but not as wet as the individual year. So lots of information there. You can look at this for any of our sites, and you can also, that was for water year, you can also look at it in terms of seasonal runoff for that April to July period. One other thing I can show you that's on here is this box called verification. If you want to know, you know, it's one thing, we have our probabilistic information that tells you, you know, 10% exceedance, 90% exceedance, 50% exceedance. Well, how good are those forecasts? You know, verification, we've done that work for most of the Sierra locations. I think all of the Sierra locations, but not for everywhere else. But where we've done it for, you can look at, this is verification information that kind of shows you what the reliability of those forecasts are. So this first plot is a correlation plot. There's some scatter plots. These are for the April to July volumes. You can see the main thing to get from this is there's not much skill in the fall here, because again, we don't know much about the snowpack at this point. But by the time you get to January, February, we start to get higher correlations with our 50% exceedance and the observed of what actually happens. And then as you get later in the spring, that gets even better. And then of course, by the time you get to July, you know, everything lines up because it's all in the bank by that point. So it's the forecasting is, you're just forecasting the residual, which in July, there's not much precipitation expected. So it's going to be based on what's already happened. Now, if you want to learn more about all these different verification metrics, there's this box right here about these plots and help. if you click on that, it'll kind of give you some background on what all that means. But just wanted to kind of point out that's what's available there. The other thing we have is under this water resources, another thing you can look at are observed flows. So you can see what's happened for the water year to date, and a quick visual plot of you can see that Central Sierra standing out as well above normal so far this year. Most other places are kind of near normal. Southern California, of course, has been dry, so it's below normal. There's even been some below normal just because it's normally pretty wet up through this region in Northern California. A little farther north, especially from here northward, they've been getting a lot of precipitation, so they're running above normal up there on the north coast as well. That's for the water year to date. You could look at the previous. Oh, that's not available right now. We're going through some reconfiguration of our computer systems now, so some of this stuff for the next week or so might be a little flaky, but you'd be able to normally look at the previous water year flow percent of average for all of 2017 to see where it stood. But that's just a nice quick visual of where things are at there for observed flows, and then you could even look at month to date, how are we doing, and the seasonal accumulation table. This gives you in tabular form kind of where things are at for the season so far. Also up here you can check out precipitation and see where we are as percent water year percent of normal for precipitation by HUC group, and then we also make available what was shown earlier, the Northern Sierra Index from the Department of Water Resources. That's just a nice convenient way to call this up, and you can look at where we're at there, and also the San Joaquin and Tulare indexes are there. And then you can look at snow under this. This is our, what you're going to look at is the simulated basin percent of average. So this is what our model is showing for what we have in terms of snow water equivalent. So kind of running below normal up here. Things have been warm so far. There hasn't been much accumulation. The mountains aren't that high here in the Northern Sierra. They're a little higher in they're much higher in the Southern Sierra, but not as much precipitation has occurred down there, so things are still below normal for the most part. Some areas are near normal, but that's a way you can visualize where things are at the snowpack wise. You can look at things in terms of lower basin, and then percent of April 1st average snowpack you can look at. Here's the simulated basin snow water equivalent. So this gives you can read out, how much water is actually in the snowpack according to our modeling system. And even a grid here, snow water equivalent grid. Showing up there. And then another nice thing in the spring, you can look at things like the 7-day change in the snow water equivalent. You can kind of see what's melted off, and percent of April 1st averages, which are more significant in the spring too. There's also, we have a box for reservoir storage. This is a little bit of a one-stop shopping location, but this shows visually quickly where things are at for the reservoirs. You can see Oroville standing out because, as it was mentioned, they're keeping it low. They have a new spillway that's still not complete, but they've completed it for this year. It can handle up to 100,000 CFS if they had to, but really they're trying to not use the spillway at all, and so they're keeping the reservoir pretty low and just operating the powerhouses to keep move water through, and hopefully not have to engage the spillway. But they can use the spillway if necessary, if it gets up high. And that work is supposed to complete next year for that spillway. But also you can, it's got the the Department of Water Resources plots for current reservoir conditions. You can look at things visually this way as well. around the state. And then one other thing to show you is, you know, precipitation. If you go back to our home here, actually under weather, there's a little obscure to get to, but here's how you get to this. Observe precipitation. You can look at, every day we quality control precipitation, so you can look at the latest 24 hours, usually about 8, 9 o'clock in the morning. This is done. It'll show you what's fallen in the last 24, which, well, you know, it's fairly significant for this last 24 that we had. Pretty wet up in the Sierra there with 2.5 inches of precipitation. And you can also, you know, you go back and you can look at the past 7 days, just above there, to see what the accumulation's been around the state. And, you know, under this, you can look at different periods, 6-hour periods, 24-hour periods. The finest we analyze the precipitation or quality control it is in 6-hour time steps. So 6-hour chunks, but not, we're not yet doing hourly on that. If you want to look at the things on a national scale, you can scroll down. Every day we'll upload our quality controlled precipitation to a national analysis. And so halfway down the page, this under NWS precipitation analysis, if you go there, you can look at the whole country and see what is showing up there. So like if you want to look at the last 7 days, what's the accumulation been across the country, it shows it all. Last 14 days, you can do the last 30 days, last 60, 90. You can do water year to date on there. You can zoom in and look at things in terms of just our River Forecast Center, California, Nevada River Forecast Center, and it zooms in. And then if you want to do like percent of normal, you can look at things like that. You could look at what's actually fallen in absolute terms. You know, you can see quite a bit already this year. Plot the normal, and then the departure from normal, and percent of normal. So lots of different ways to look at precipitation to kind of see where things, and definitely Southern California stands out as dry for this water year so far, and Central Sierra kind of running pretty well above normal. Most other places kind of just near normal, maybe a little wet up on the North Coast in a few spots. There's a lot more I could show you, but I thought this was a good teaser, introduction, kind of get you started on you can always call our office to get more help on navigating the system. It's not the easiest website to navigate, but there is a lot of information available on it once you kind of know where things are. With that, I'll turn it back to Amanda.
Great. Thanks, Alan. We're going to switch to the next speaker here, who's going to do on the Center for Western Weather and Water Extremes, their website, and some of the tools that they have. I will be putting all these links into the summary on the web on drought.gov and the summary. So if you missed any links, we'll make sure they're in there for you.
All right, thank you, Amanda. I am Brian Kosnick. I'm a researcher at the Center for Western Weather and Water Extremes, or CW3E, and I'm just going to take you through a couple of the tools that we produce at the center here. So CW3E is actually a research center, but we do produce some near real-time or operational tools on our website. CW3E focuses on the weather extremes in the western U.S., and currently our main focus is on atmospheric rivers. So the tools I'm going to show you are actually more geared towards forecasting atmospheric rivers as opposed to just precipitation. We do have some precipitation products on our website too. This is the homepage for CW3E. You can find it at cw3e.ucsd.edu. And the first thing that I'm going to highlight for you is something that you would see relatively often if you come to our website, is these CW3E AR updates. And basically what these updates are they're a forecast of an upcoming AR, and basically it puts multiple different forecast products and tools both from CW3E and some other agencies, some of which that we just saw in the last presentation, basically into one place, and we add some of our commentary and interpretation onto these forecasts. So they typically focus more on the forecasted AR itself, but they also include some information on precipitation and discuss some potential flooding or freezing levels or other potential hazards that may be in the forecast. But the tools that I'm going to focus on are on our atmospheric river forecast page. So you can get that by clicking this image right in the middle here, or through our menu where it says AR, IVT, and forecasts. So that will take you to this page here. And basically this is sort of the main suite of all of our different AR forecast products. And two of the variables that I'm going to really be discussing the most and what you'll see mostly on this page are IWV, which is the integrated water vapor. And basically this is just a measure of how much water vapor is in the atmosphere. And then IVT, which is integrated water vapor transport. And basically this is a flux of that integrated water vapor. So it's a measure of how much or how fast and how much of that moisture is being moved in the atmosphere. So the first products that I'll show here are just some maps of IWV and IVT from the NCEP GFS and the NAM models. And we produced them on 5 different domains, as you see here. And if you click on one of those domains, you'll get brought to a page like so. And basically it just shows a map of the forecasted IVT or IWV. And we produce these out to 180 hours. And you can scroll through the different images here with your arrow keys, and you can scroll from IVT to IWV, from GFS to NAM. So we produce those out to 180 hours, as I said, and there's different domains and geographic regions that you can scroll through between there, and you can select them here. So the next product that I'm going to highlight here is our meteorograms, and let me is our meteorograms that are based on also on the GFS here. And basically this is a 3 or a 7-day forecast at a given location. And you can select the locations based on latitude and longitude, and we'll highlight based on a red dot here what location you are looking at. And unfortunately there's not really much of an atmospheric rivers in the forecast right now, so that's a little bit better of a plot. You can actually see some things. But basically what this is showing is a forecast at a given point. This is a time height cross section essentially. So our x-axis is time in forecast hours. So our 0 or current time is on the left, and forecast hours are increasing as we move to the right. This is a 7-day example, but there's also one made for 3 days. And then our y-axis is vertical, so height expressed in pressure. The top section, the color fill is showing that IVT, so the moisture, the movement of moisture in the atmosphere. The wind barbs are wind is shown by the wind barbs here, and the black line is showing the 0-degree isotherm. And this gives us an idea of freezing level, so we can get an idea of whether precipitation will be falling as snow or as rain. The middle plot is showing precipitation. 12-hour periods are the bars. The 3-day plots are in 3 hours instead. And then the line is showing, again, that height of the 0-degree isotherm with respect to the ground height, which is the dashed line there. And then the bottom plot is just showing IVT and IWV throughout the forecast as well. So the next couple of tools that I'm going to show you are using the GEFS, which is an ensemble model. And basically an ensemble model produces multiple outcomes instead of just the one like I had showed in the previous ones. And one of the easiest ways to see the benefits of an ensemble model is by these thumbnail plots that I'm showing here. And basically every one of these different plots, there's 20 of them here, are a different ensemble member. So they're a different outcome that this model is producing. So looking at these different plots, we can see all the different potential forecasts that this model is producing. Another way to visualize this data is using our IVT plume diagrams. These are made for 7, 10, or 16 days at various locations along the U.S. West Coast. Again, similar to the plot above, if you select a different location, the map on the left will show you what location you are looking at. And basically what these plots are showing you is the IVT at that given location throughout the forecast. Again, 0 is on the left here, and our forecast time is increasing as we move to the right. So each one of these thin gray lines is an actual ensemble member. The red and the blue lines are there to represent the maximum and minimum values of IVT at that given forecast hour. The green line is the mean of all the ensemble members, and then the black line is the control or deterministic forecast. So these plots actually show nicely how the ensemble members start to spread out as you get further out into higher lead times. So let me go to the 10-day. It's a little bit easier to see. But really in the short lead times, right close after the model's initialized, the ensemble members tend to agree. And then as we get further and further out into the forecast times, they start to diverge and have different outcomes. And really we can look at the spread in the model ensemble members, and the larger that spread is, the higher uncertainty we have in the forecast. So the last ensemble tool that I'm going to show you has sort of become an iconic tool for CW3E, and that is the AR landfall tool. And basically this tool is showing the probability of AR conditions along the US West Coast for the next 7 or 16 days. I'll highlight the 7-day forecast here. And basically what it's showing is the AR conditions along these points along the US West Coast. So the y-axis is, again, all of those different points. The x-axis is time. However, in this case, it's actually going from right to left. So our 0 hours on the right side, moving out towards the left. So basically what it's showing is at each given lead time or at given location, it's showing the percentage of the ensemble members that are predicting IVT over a given threshold. So for this example, we're using 250. So for example, if we looked at the 1-day lead time at 50 degrees north, we're seeing a purple coloring. So all of the ensemble members are predicting IVT over 250 units at this location at this time. When we see some of the other colors here, as you can see further out in the 3 to 4 day lead time, that's showing that not all of the ensemble members are agreeing on those AR conditions, so there's a little bit more uncertainty in the forecast. And we produce this plot at various different thresholds for IVT, just so that we can get an idea of the strength of any potential ARs that are incoming. So the last tool I want to mention on this page is the West Wharf. The West Wharf is a version of the Wharf model that's been tailored to West Coast weather extremes that's run in-house at CW3E. This will begin running in near real time on December 1st with twice daily initializations. So we produce multiple different products and maps similar to some of the outputs that I showed before. But this isn't online yet. During the warm season, we make some adjustments to it and do some verification on it. But we will start running it in near real time by the end of this week, actually, is planned. And the last piece that I want to highlight that CW3 produces is what we're calling the interactive maps. And you can get there either from this link here on our homepage, or if you go to Forecast and Interactive Maps, it will bring you to this page here. And basically, Interactive Maps is a new suite of tools that we launched a couple of months ago that's taking advantage of web mapping services and interactive technologies. So basically, they show a variety of observations and forecast products on an interactive Google Maps-like interface. So I'm going to highlight one of those pages for you here. I'm going to show the watershed precipitation forecast. And if you were to click on that, it would bring you to this page. And basically what you can see here is you get sort of an interactive maps type interface. You can drag and move it around. Oh, that's not what I want to do. Sorry, you can zoom in and zoom out on this page and basically do like you would on a normal Google Maps interface or some other type mapping program like that. There's also a few different layers you can use, and these options change per the different pages. But for this page, what I'm going to highlight is that this page is showing the 10-day GFS precipitation forecast over the Huck 8 watersheds, which you can see in the color field here. If you hover over one of the watersheds, it will show you the total precipitation that's forecasted over the next 10 days. It shows up under our logo here on the top there. And if you were to click on one of these, you'll get a plot on the right that shows the 10-day precipitation and accumulation in the line there, and then also the 3-hour precipitation bars here. It also has these forecast points on here, which are the river stage forecasts that we just heard a little bit about in the last presentation from the river forecast centers. And if you were to click on one of those points, you'll get a hydrograph of the observed forecast, the observed river stage, and then the forecast stage over the next several days. So this is just one of the tools, one of the pages that we have here. There's 5 total pages here that are all set up in a similar interactive maps types setting like that. And basically, and they all highlight different types of forecast products or observations. So I encourage you to go on there and take a look and see what else is on there on the other pages. And all of the pages have descriptions at the bottom that tell you what's being shown on there and gives you some of the highlights that they have there. So what I've shown here is sort of a quick highlight and quick sample of some of the tools that CW3E produces. We do produce some other types of observations with satellites and precipitation and other tools like that. So I encourage you to take a look at our website and look around and see some of the other tools that we have to offer. If you have any questions or comments on any of our tools, please feel free to contact me or any other people at CW3E. You can find emails in our People's page here. The easiest way, if you have a question about the website, is to use this contact webmaster link at the bottom. That'll connect you directly to me. So thank you, and I'm going to turn it back over to Amanda.
All right, thanks, Brian. I'm going to try to wrap us up here quickly with another set of tools from the California Nevada Applications Program. Obviously, those of you that are longtime listeners with us know that CNEP has been a good partner in developing these webinars with NIDIS and other programs. And I just want to highlight a couple tools that we have on the CNEP website. If you go to cnep.ucsc.edu, they are the local NOAA RESA program, which is the Regional Integrated Sciences and Assessment Program. Their mission is to improve resilience in California, Nevada by providing decision makers usable climate info through integrating cutting-edge physical and social science. You can find a lot more information on their website, including climate handouts and other climate tools. But for right now, for time, I'm going to focus here on this water storage tracking in California tool that they have. This hasn't been updated yet for the current season, but this tool is developed by Mike Dettinger from the USGS, and it tracks water storage in the Sierra Nevada. This basically combines daily storage from the 28 reservoirs, which are these red dots on the map here on the right, with snowpack totals for the Sierra. Combining snowpack and reservoir is important because snowpack is that natural reservoir for us in California, but also the timing of the changes in snowpack and reservoir is also important. And as Mike has put it, to get a more holistic view of the water supply understanding and how we can track precip throughout the year. So for example here, you can see we have throughout the winter, and this is from last year's example, we'll track throughout the water year from October 1st to August 1st. What the current reservoir looks like, the reservoir totals, such here is in red, and then reservoir plus snowpack, such as here in orange, compared to what the normals are from 2000 to 2015. So blue here is your reservoir normals area, and the gray here is your reservoir plus snowpack normals from 2015 to 2000 to 2015. Some of these stars here are pointing out the key years, with the star here being the 1983 wet year, the upward facing triangles here being examples from the 2011 year, and then the downward triangles being from 2015. And those are to give us comparison to wet year, a recent wet year, and then also a recent dry year. And as I said, this is from last year's total, so Mike tends to update these periodically throughout the year. So as we're headed here towards December 1st, hopefully we'll get a map soon as we start to actually get some of these AR storms. And you'll be able to track real time throughout the year how we're doing with reservoirs plus snowpack. That was the main tool I wanted to show. We also have some on CNEP for precipitation tracking, snow, other not necessarily related to here, sea level, and these historical precipitation percentile maps as well. With that, I think for time, I'm going to go ahead and close the presentations. We do have a few questions if the speakers are able to stick around a little bit at the end. If you have any questions, please go ahead and type them in. While people are doing that, I'm going to take a chance to say thank you to all our speakers today for presenting. As I said at the beginning, all these slides, the recording and the 2-page summary will be on drought.gov in the coming week or so. And our next webinar is scheduled for Monday, January 22nd. You can find that registration already on drought.gov on the calendar website. And the info will also be sent in the post-webinar email that goes with this. And with that, I can hop over to some questions. The first one I think would go back to Andrea, which was, what is the relationship between the jet stream and the temperature precipitation outlook? The patterns resemble a jet stream pattern.
Well, yeah, when we're in La Nina conditions, the general storm track, which is how the jet stream is moving with it as well, the storms tend to shift further north, which is why you see that general area of in the north of above normal precipitation and cooler than normal temperatures. So that the whole storm track, which would be pushed in with the jet stream, that's all shifted to the north. So hopefully that answered that okay.
Yeah. And then we have one other question, which I think would be for Ellen. Does the CBRFC, so the Colorado River Basin website, have the same tools as CNRFC? The format/interface used for these tools are very intuitive and helpful. So a compliment and a question.
Yeah, thanks. They have similar, but they're not the same format, and I don't think you can get the same information exactly. We are working on putting up a page that is kind of a more common features one, that it will be available for, that'll have Northwest River Forecast Center, Colorado Basin, and California, Nevada all together, all that information, so you can look at it in a consistent sort of format. But we've kind of the blessing and the curse of all these independent river forecast centers all working is that there's been a lot of creativity, but also a lot of individuality and not a lot of consistency between them. So, yeah, check out their page and see what they have, but it's not going to be quite the same as the way we show it.
All right. I don't see any other questions right now. Thank you again to our speakers and everyone who joined us today. We hope you found this webinar informative. If you want any more information on our 90s activities or partner activities in the region, please contact me. And there is a post-webinar survey, so if you close out the webinar, you'll get a survey. We do listen to those because they help us point us to the right timely topics that different attendees want to hear about and things like that. So with that, I'll go ahead and close the webinar. Thank you.
All right, thanks.
Thanks.